Özellikle bu robotik süreç otomasyonu, robotlar ayda 180 bin saat çalışıyorlarmış ve 400 kişinin yaptığı işe tekabül ediyor. Gerçekten rakamlar çok çarpıcı. Tabii bu zirvenin bu yılki teması her şey bir soruyla başlar dedik. Sorulara yanıt veren, metin hatta kod oluşturan yapay zeka temelli sohbet robotu ChatGPT. Herkes bahsetti. Kasım 2022'de çıktı ve tarihte en hızlı büyüyen internet uygulaması oldu. Aslında bu dijital dönüşümün ne kadar hızlandığının bir göstergesi ve her geçen gün yeni bir ürün bu dönüşüme katkıda sunuyor. Örneğin Eylül ayında ChatGPT'nin kullandığı çip kapasitesinin 2 katından fazlasına sahip olduğu duyurulan yeni bir yarı iletken çip çıkarıldı. Yapay zeka alanında önde gelen bir startup olan Samba Nova tarafından. Zirvemizin aynı zamanda altın sponsoru olan bu şirketin EMEA bölgesi genel müdürü Alex White bugün aramızda. Kendisini alkışlarınızla sahneye davet edelim.
Merhaba. Benim ismim Alex White. And that is how far I have trained my Turkish language model. So, unfortunately, we have to continue in English. I hope that's okay. I'm going to talk to you about Samba Nova, who we are, but more importantly, why we exist, why it's important to think about what's coming in the future, not just what you have today. The many great innovations that you'll see at the show today is just the beginning. These models are going to get bigger. Your organization will need to span hundreds or thousands of models. Everyone in this room will have their own AI co-pilot. Everyone. Every task, every corporate activity will be understood from a data perspective. That is where we're headed. And the architecture that we need to get us there has to be more cost-effective and better performing than it is today. And I'll tell you why. So who is Samba Nova? We're a startup company. We've been going for 6 years. However, our chief executive, Rodrigo, ran systems architecture at Sun Microsystems and then Oracle. His team built every Spark, every Super Spark RISC processor for 15 years. And in 2002, he acquired a company from Kunle Olakuten called Afara. Kunle is a Stanford professor. He still works at Stanford in electrical engineering. He built a company that defined a way for servers in the data center to run multi-core processing. So every data center in the world runs Sun servers with multi-core processing that Rodrigo and Kunle built together. So we're a startup with 25 years experience of systems architecture. The third co-founder, Chris Ray, also a Stanford professor of computer science. He's an expert in data. He has the presidential award in the US called the MacArthur Genius Award for his work with data. He invented a technique called deep dive, which creates enormous inference sequence change from very large data sets. And this enabled, for example, the Human Genome Project to open new discoveries. And he was awarded this prize. He's also responsible for a team who invented the concept of flash attention. Flash attention is how AI inference models work today from a workflow perspective. So this is our brains trust. And they understood in 2015 that AI was going to change everything, as I described. It's unstoppable. It is about efficiency, productivity, but it's also about opportunity. It's about the future. It's about the future of Turkey as a nation. It's about your children, their education, the skills that they learn. Opportunity exists beyond your imagination. And of course, we have to do it in a responsible way, but they understood that this data opportunity is so massive that the current architecture, the CPU, the GPU, the same architecture, instruction set architecture, this is not fit for purpose for very large data. You have a data flow opportunity, and you need a data flow architecture. So this is our idea. And we attracted $1.1 billion. We're the largest, best-funded AI platform startup in the world. And we have very long-term investors. Where are we today? So we've come from, in the past, your children, my children, actually. Thank goodness, I have one who's learning computer science. We've come from learning the machine code, the machine's language, to being able to use natural language, speaking in English, and I hope soon in Turkish. These models, the generative AI models built on English, are absolutely enormous, trained on very, very large sets of data, as big as the internet in some cases. They're enormous, and they're very good at reasoning, and they will continue to have a purpose to do this fantastic reasoning ability. But in the enterprise, in your government services, in your businesses, you will not put your data into a public cloud closed model where Microsoft owns the intellectual property of that model. Because if you do, you're giving your value to Microsoft or to the other model provider. You will want to do something different, still using reasoning in some of these very large models, but building your own capability. And that capability will be defined by domain, finance, HR, sales, marketing, supply chain, customer invoicing, etc., and tasks within each of those domains. That they will be individual expert models that you will collate, fine-tune, keep up to date in real time, yesterday's information, not 2 years ago information. And you want to secure that data. You want to keep it private, isolated. It's a granular, modular design of architecture, not a monolithic design, which I'll talk about in a bit more detail. So how to do this? The cost of training GPT-4, we don't know exactly, but look at the loss that OpenAI made. That is a public record. They're losing hundreds of millions of dollars a year. They're not losing it, they're spending it training these models. And enterprises can't afford to do that either, not many. In fact, the only ones that have done are some very big, usually American, very big monopolistic companies with thousands of engineers and lots of money. And they are currently charging as a service for you to make use of these models. How to do it yourself. So, going back to the present day, as I mentioned, ChatGPT-4, fantastic. We think it's the largest closed source model out there. We don't know exactly, but roughly 1.8 trillion parameters, weights and checkpoints within the model, 1.8 trillion. The largest open source model that is open, not closed, that is non-proprietary, is the Falcon, 180 billion. Again, both these models are super in terms of reasoning. They're very large quantitative amounts of data, and they're very skillful at what they do. But what they're not good at is the cost to serve, especially for training, but even more so for inference, is really, really high. They're incredibly difficult to navigate in terms of who's accessing the model, what access control should they have inside the model, how do you ensure that a rogue agent or somebody who's in a sales role doesn't have access to finance information that they shouldn't have access to. How do you put that kind of granularity and that control and access? And also importantly, the maintenance of these models is equally big. It's just cost upon cost upon cost upon cost. The second thing we know about the current state is that these LLMs, whilst they're very good at reasoning, because they're so large and they take so much compute, they're really only good at one task at a time. So if you have a complex 4, 5, 6, 7-step task that you want the models to do, really the only way to do it is one task at a time. And this has given rise to a number of application frameworks, LangChain, Llama Index, Semantic Kernel, where you can, from a workflow perspective, define which elements of the data, which models you want to question and set up a workflow so that you ask the first question to the first model, take that answer, input it to the second model, take that answer, and so on. And you can do that across multiple models, and you can do it between models and embedded data in vector frameworks. It's a, if you like, greater efficiency for the brittleness of these monolithic models. But I can tell you that there is a different way to think about this. And this is what we are calling composition of experts. This is thinking from our engineers. Stanford University, Hugging Face has published blogs on this concept. Composition of experts. The idea is that, what if you could hold up to 5 trillion parameters of data? Remember, GPT-4 is 1.8 trillion, so nearly 3 times more. Hold 5 trillion parameters in a single runtime in memory. Then you could think about much more efficient compute usage for inference, which would result in longer sequence lengths from these models. And I can tell you, 32K sequence length from ChatGPT-4 is not enough to understand your contract database, your supply chain, your entire workflow end to end. It's much, much bigger than that. And so the chatbots and the agents, the very sophisticated tools that you start see emerging, the chat agent can only deal with the information that the model is outputting. And if that's 32,000 tokens in terms of sequence length, it's a snapshot of the whole picture. What if you could do 256,000 tokens? What if I told you that SambaNova is working in US research labs in North America, delivering 1 million tokens sequence length? It's about efficiency, and it's about the architecture. The other element of TCO that you need to think about is what is termed tokens per second. The way to think about that is the number of knowledge workers in your organization. So 300 tokens per second is world record performance, because currently the GPU architecture, which is this instruction-based architecture, tops out, its top performance is 125 tokens per second. And after that, it crashes. The system crashes. It cannot scale beyond that. Now, that is a lot of knowledge workers, but large organizations will have thousands of knowledge workers accessing these models. And 300 tokens per second, we think, is roughly 3,000 knowledge workers a day accessing your model workflow. As I mentioned, it needs to be done in a modular way. So the composition of your architecture needs to provide access control and granularity, but also so you're not approaching everything at one time as one big monolithic effort, but you go department by task, as you grow knowledge skills, as you bring new data scientists, ML engineers into your organization, as you change your ML ops, as you change your organization to deal with the future AI-based companies that you will be a part of, you can add as you go. And up to 5 trillion parameters in a single runtime on one node of compute. That avoids the other problem with monolithic models, this idea of fine-tuning different elements of the model. Each time you do that, you lose some accuracy, and you compromise some performance in the previously trained, fine-tuned areas of the model. So you want to avoid that alignment tax and give control. So this is how we do it. This is our, if you like, latest invention. It's not as big as this, don't worry. It's about the size of my hand. It's a 5 nanometer silicon fab. We make this in Taiwan, in TSMC. It has reconfigurable silicon. It has 1,040 reconfigurable cores on the silicon. And reconfigurability means you can start to change the addressable compute and addressable memory for different model types. So some large, some smaller, can all be held within a single chip. It also allows you to do multi-tenancy at the chip level. But the most important part of this invention is on the right-hand side. the memory. So this is per chip. At a system level, there are 8 chips. 1.5 terabytes of DDR memory per chip is 12 terabytes at the system level. That's how you hold 5 trillion parameters in runtime. That is significantly more than existing architecture that everybody is using. Secondly, and more importantly, we've introduced this intermediary adjacent, very, very fast HBM3 memory, 64 gigabits. This is how you do inference at incredibly high speeds, very efficiently. And lastly, on-chip memory of 520 meg per chip. This is the data flow. So these 2 layers is what is allowing you to do spatial modeling, spatial problems, as opposed to just using brute computer force to drive massive parallelization to get the results. You're doing things in a more sparse way, with greater efficiency, much faster, and much greater TCO. So this is what it looks like at a system level. As I mentioned, 12 terabytes. So imagine, I think there are 3,000, our colleagues from Meta in the room will tell you at the break how many Llama 2 models there are on Hugging Face. I think it's around 3,000. There are a lot. Imagine that's your organization. It will be, some of you. Some banks in America, some other large organizations already running thousands of models. So imagine that all the models in Hugging Face, now you want to run those, right? Well, actually, you can, up to 5 trillion parameters in 12 terabytes of system memory. Then at the next 2 levels, between the super low latency and high speed of this memory layer, this is what is allowing you to basically take entire workloads or models or parts of models into memory, into single runtime. That's how it works. So let me go into a little bit more detail for some practitioners in the room. So this is how you would think about it from a diagrammatic perspective. So typically, workloads today, you're using containers, probably with Kubernetes. So you think about a job, and you take the container that's holding the model you want to run, and you schedule with Kubernetes for that job. And Kubernetes reserves the compute and the memory that you need and dedicates it to that model. Dedicates it. So what that means is another model can't use that memory. It's dedicated, or it's very hard to share resource in this approach. So if you have 10 models, the DGX has 8 GPUs. You need 2 nodes of DGX to run 10 models. Whereas this is a completely different approach. As I mentioned, you can hold all those models in a single runtime. You can interrogate them using a workflow, like LangChain, any router-type workflow. You can decide either in a deterministic way, you can say, these are the models I want to answer the question or the problem that I'm trying to solve, and you simply run it in memory. And as I mentioned, up to 5 trillion parameters. If we take the Llama 2 7 billion example, that would be 714 Llama 2 7 billion models running in one runtime. You would need 24 DGX nodes to do that. This is what it looks like then in terms of how we imagine the overall workflow, what we're calling composition of experts. It's simply the concept that your entire model store, however large that is, and don't forget it is going to grow, you're going to want it to grow, you're going to want to add more expertise. You take your entire store and make it available to a user inputting a problem statement, a request, to then interrogate this model store sparsely based on what you need to answer the question, based on access control that you've set up, based on users being restricted to certain elements, certain models, based on everything you know so far, just in a different architecture. And there are many different ways to do this. I'm just going to give a couple of examples. Rule-based. So in the rule-based scenario, using LangChain, for example, you'd say, I want to take 10 models to answer this question. The question might be from accounts. How many customers do I have that have purchased this product because you know the product has a recall? And you also want to know, have any of those customers had a problem with this product? Are there any reports of errors, issues with the product? And you also want to know from legal, what is our legal position about the responsibility and the service level that we need to deliver? And you also want the sales and marketing team, their model, to be able to communicate with them what the message is you want to push out to your customers, what you want on your website. So you choose the models in this imaginary workflow that I just invented on stage, but this then automatically, from your model store, selects the models, the expert models that it needs to answer the question, and runs the job. The other way of doing this is with intelligent routing, where you still have your model store. Again, imagine this is 3,000 or hundreds of models. But in this case, you take another Llama 2 7 billion model, and you train it to be a classifier. So that model knows where all the experts are, and it knows user access control for each expert. So you simply run the model, this time probabilistically, and it reasons how to answer your question based on who's asking it, what access control they have. Everything's secure, everything's private, and don't forget, everything's running still, because we're only using 5 trillion parameters on a single node of compute. So this is, again, not life science, but it's much bigger than this. This is a rack with a single node. That's what it looks like. And that is what you're comparing with. So the more you buy, the more you save. I didn't go backwards. I went forward. I'm just going to try and get this last slide back up if I can. Does that come up? Thank you. So thank you for listening in English. I know that may be difficult for some people in the room, and I'm responsible for the region of Europe, Middle East, and Africa, so I'm going to be here on a regular basis. I'm actually leaving here almost immediately to go to Ireland, where I'm meeting with the government of Ireland. I've been here all week this week, had a fantastic week, and we've actually met with ministers of state, and we've talked about what is the strategy for AI in Turkey. What should it be? What about a Turkish language generative model that you can use within your businesses? What's the strategy for that? I've also met with business leaders and with IT specialists asking very similar questions in terms of how do you think about developing this? What is it going to take to do this cost effectively, do this in a modular fashion, at the speed that you can deal with investment costs that you can predict, with supply that is predictable. I forgot to mention earlier, you can't actually get hold of GPUs because the whole world is trying to use them, or certainly not for your private data on premise. SambaNova have spent a portion of that $1.1 billion. We have plenty of supply. And our partner here in the region is Exodus. They're in the meeting place outside the door, so I would urge you to go and speak with them and have follow-up questions if you have them. They have some technical experts on their stand. We're showing a demo. It's a video, but it's a real demo, real live video of a legal use case whereby we asked ChatGPT-4 to write from scratch a mutual NDA document. And we asked the same question of SambaNova Suite with our composition of experts model, and it is running 6 times faster. And it runs 6 times faster because of everything I told you. It's holding the models it needs in memory rather than one task at a time in a workflow that is massively larger compute, therefore less efficient. And whilst there will be room in the next 10 years for GPT-4, it's a fantastic model. Falcon, fantastic model. they have a purpose. But you need to think about what's your strategy for your company, your data. It will be private. You won't be sharing it with somebody else who owns the model. It'll be yours. And you'll be going at different speeds. But my final message is, come and talk to us. Let's problem solve together. We can help you. And thank you very much for your time.
Alex White, thank you so much for this inspiring speech. It was somehow mind-blowing for me, I must admit, but we have learned a lot about the critical technical infrastructure of this generative AI. I know that he is going to make it to the airport. I hope he can make it easily because of the Istanbul traffic. Maybe we have to ask some questions also for generative AI to solve the traffic problem in Istanbul. Alex White gerçekten çok ilham veren bir sunum yaptı. Yapay zeka çağında öncülük edenler kazanıyor ve buradaki Türkiye temaslarında Türkiye'deki devlet yetkilileriyle görüştüğünden de söz etti. Umarız Generative AI konusunda Türkiye'de de öncü adımlar atılır. Bu konuda öğleden sonra da kamu tarafında neler yapıldığını biraz daha ayrıntılı konuşacağımızı hatırlatalım.